Now we are going to solve some typical problems. The first one is examine coplanarity of the point P, that is with coordinate 1, 1, 1, Q with coordinate minus 2, 4, 1, point R with coordinate minus 1, 5, 5, and point S with coordinate 2, 2, 5. Also, determine the type of quadrilateral formed by them, that is four-sided figure, if any. So in this problem, we have to check whether these 4 points are coplanar or not. That is, they lie in same plane or not. As we know, if we check that 2 points have same direction and opposite direction, or they lie in same plane if two lines are parallel intersecting. If we prove two lines are parallel or they are intersecting and have common point of their intersection, then we can say that these points are coplanar. So to check the coplanarity, we will follow the question as. Now we can say answer or solution is that first we will find position vector of PQ. Then we can check whether they have same direction or parallel or not. So vector PQ have the position vector. Writing the position vector of Q, that is minus 2, 4, 1 minus position vector of P. That gives a position vector of vector PQ. It becomes minus 2 minus 1 minus 3 comma 3 comma 0. Now we will check out the position vector of QR, that is minus 1, 5 and 5, position vector of R minus position vector of Q, that is minus 2, 4, 1. That gives 1, 1 and 4. Now the next one, SR, and that is the position vector of R minus 1, 5, 5 and position vector of SR 2, 2, 5. That gives minus 3, 3 and 0. Now the last one side we can form, that is PS. PS is 2, 2, 5 minus 1, 1, 1. That gives 1, 1, 4. So from above we can see PQ vector is equal to minus 3, 3, 0. That is 1 times minus 3, 3, 0. That is 1 time vector SR. That is, here k is equal to 1 greater than 0. Then vector PQ and SR have same direction. That is, vector PQ is parallel to vector SR. And also vector QR is equal to 1, 1, 4, or we can write 1 into 1, 1, 4, that is equal to vector PS also. Here again k is equal to 1, which is greater than 0. Therefore, vector QR and PS have same direction. That is, vector QR and PS are parallel. That is, vector QR is parallel to vector PS. As we have QR is parallel to PS and PQ is parallel to SR, that means all the points are coplanar. That is, lie in one plane. Now we will check which type of quadrilateral is formed. So for this we will find the length of all sides by finding their magnitude. That is, magnitude of PQ vector is PQ, which is equal to under root 3 square plus 3 square plus 0 is equal to under root 18. Similarly, magnitude of RS will be RS is equal to minus 3 square plus 3 square plus 0, that is under root 18, and magnitude of QR is, that is 1 square plus 1 square plus 4 square, that is 16, that is under root 18. Also, PS length under root 1 plus 1 plus 16, that is under root 18. As we see, 4 lengths are equal, but we have, as PQ is parallel to SR and also PQ is equal to length and length of SR is equal, and also QR is parallel to PS and length of QR is equal to length of PS vector. That is, if pair of two sides is parallel and equal, then PQRS is a parallelogram. Now we will check its diagonal. Diagonal is PR. First, making the diagram, as PQ is parallel to SR. If we take PQ side here we have to take SR in this direction, and we have taken this side as PS and we have direction as QR. So till now we have, this is a parallelogram. Now we'll check its diagonal. Diagonals are PR and QS. So we'll find the length of PR by distance formula. That is 1 plus 1 whole square plus 1 minus 5 whole square plus 1 minus 5 whole square. That gives 2 square, that is 4. 4 square is 16. 4 square is 16. So it gives under root 36. As is the length of side, so it is always positive, so we will take as plus 6. Now we will find the second diagonal, that is QS, which gives minus 2 whole square plus 4 minus 2 whole square plus 1 minus 5 whole square. That gives under root minus 4 whole square as 16 plus 2 square is 4 plus minus 4 square is 16, that is under root 36. That gives positive value of 6. That is PR length is equal to QS, that is diagonal of equal length. As now we'll check the midpoint of these diagonals. Midpoint of PR is sum of coordinate over 2. 1 minus 1 over 2, 1 plus 5 over 2, 1 plus 5 over 2. So we get 1 minus 1 is 0, 0 over 2 is 0, 6 over 2 is 3 and 6 over 2 is 3. And now we will check the midpoint of QS. That is minus 2 plus 2 over 2, 4 plus 2 over 2, 1 plus 5 over 2. So that gives 0, 3, 3. So as we see, midpoint of diagonal PR is equal to midpoint of QS, and as PR is equal to QS and as we have PQ is equal to SR is equal to QR is equal to PS, then parallelogram PQRS is a square, because this is the property of square. So PQRS is a square. So this is the way how can we check out the points are collinear, coplanar or not. After check the coplanar, we will check which type of quadrilateral is formed by using first of all whether it is formed a quadrilateral or not. First of all, that is easy to check out the parallel side, as we have their coplanar, that means two sides are parallel. Then we check equality of that side, then their diagonal, then midpoint. If all that is happened, then it is a square, otherwise it is a parallelogram. Now the next problem is using directions. Examine A with coordinate 0, 2, B with coordinate 2, 4 and C with coordinate minus 2, 0 are collinear. That is the case of R square. So first we will take AB, that is the position vector of ABR. 2 minus 0 is 2 and 4 minus 2 is 2, and as well as position vector of BCR. Minus 2 minus 2 is minus 4 and 0 minus 4 is minus 4, and we can see that BC can be written as minus 2 times 2 comma 2, that is minus 2 times AB vector, that is BC and AB have opposite direction. As k is equal to minus 2 is less than 0 and B is the common point. Therefore, A, B, C points are collinear. Next, we discuss the case in R-cube geometry, that is in three-dimensional space. So using directions, check P with coordinate 1, minus 1, 0, Q with coordinate minus 3, 1, 2, and R with coordinate minus 1, 0, 1 are collinear. So now the solution will be done in the same way, but here just the little difference, that is coordinate are 3. So we check first of all QR. So position vector of QR becomes minus 1 plus 3 is 2, 0 minus 1 is minus 1, and 1 minus 2 is minus 1. And position vector of PQR, that is 4, minus 4, 2 and 2. In the same way, minus 2 is common and we get 2, minus 1 and 1. Here again k is equal to minus 2 less than 0. That is PQ and QR have opposite direction. That is point Q is common. Therefore, PQR are collinear. So in this way we can check out the collinearity of 3 points, that is by using directions. Now the last problem, that is the fourth problem, is that prove that for origin with coordinate 0, 0, 0, point A with coordinate 1, 1, 0, point B with coordinate 1, 0, 1, point C with coordinate 0, 1, 1, and OA is equal to OB is equal to OC is equal to AB, BC is equal to AC. But OA, BC do not form a parallelogram. That is, we have to prove no pair of two sides are parallel and equal. If this is proved, then the above points do not form a parallelogram. Now the solution is here. Position vector of OA will be 1, 1, 0, as O is the origin. Position vector of OB will be 1, 0, 1, OC will be 0, 1, 1, and position vector of AB become 1 minus 1, 0, 0 minus 1, minus 1, 1 minus 0, 1, and position vector of BC 0 minus 1, minus 1, 1 minus 0, 1, 1 minus 1, 0, and position vector of CA or AC 0 minus 1, minus 1, 1 minus 1, 0, 1 minus 0 is 1. Now we will find the length of OA, BC and all sides as they are equal. So length of OA is, if we find its magnitude, 1 square plus 1 square plus 0, that is under root 2. And as we have OA, AB, BC, AC, OP, OC are equal, therefore by the given condition we have to prove OA is equal to OB is equal to OC is equal to AB is equal to BC is equal to AC. Therefore, we have to find OB also. So OB is also that is 1 square plus 0 square plus 1, that is under root 2. Now the turn of OC, that is under root 0 square plus 1 square plus 1 square, that is again under root 2. Now the turn of AB, AB is under root 0 plus 1, that is under root 2. Now AC, it becomes 1 plus 0 plus 1, that is under root 2. Now the remaining is BC. BC is under root minus 1 square plus 1 square plus 0, that is root 2. Hence, the given condition is proved. That is, all given sides are equal. That is, but if we see no two vectors are multiple of each other, that is, not any of above two vectors are in same or opposite direction. That is, OABC are non-coplanar points. Therefore, OABC do not form a parallelogram. Now, what figure it formed? If we draw these points in RQ plane, then we can see what type of figure is formed. So let's see. Just draw. This is the y-axis, this is the x-axis, and this is our z-axis. That is three-dimensional space. So we have the point origin, and we have coordinate A as 1, 1, 0. That is x and y plane. So A is lying here 1, 1, 0. Now take the point C, that is on 0, 1, 1. That is 0, 1, 1. So y is same. That is YZ plane, that is point C, and it have 1, 0, 1. That is Z component is same here. So this is the point B, that is 1, 0, 1. So if we join these points, OA, OB, OC, it forms a tetrahedron. That is just like figure if we say in that is three-dimensional geometry, it will become like this. O is here, this like. This O will be in upper part. That is O, B, C, A. That is three-dimensional figure. So this is a tetrahedron in R-cube space. That is just like this figure. It will appear like this. So this is our tetrahedron that is formed in three-dimensional space. This was all about the three-dimensional geometry where we get the introduction of vector and also position vector. By the help of direction we can find the collinearity, and after collinearity if they lie in the same plane then they are coplanar. So these are the basics of three-dimensional geometry.